webinar. This is Amy St. Croix with the Statistics Division. Our speaker today is the lovely J.D. Marhevko. She's Vice President of Quality and Lean for Accuride Corporation. J.D. is also a business and operational excellence executive with over 25 years of operations, QA, and lean experience in a variety of industries, including automotive, aerospace, plastics, and machining. J.D. is an ASQ Fellow and past chair of ASQ's Quality Management Division. She's also a Certified Manager of Quality and Organizational Excellence, a Certified Quality Engineer, a Certified Six Sigma Black Belt, and a trained Master Black Belt. In addition, she has been a Senior Baldrige System Assessor for the state of Michigan for several years and holds a bachelor's degree in engineering from Oakland University in Michigan and a master's degree in administration from Central Michigan University. Today, J.D. will be presenting to us on predictive warranty analysis using Paynter charts. This talk will be given at this year's World Conference on Quality Improvement, the WCQI, which is next week in Dallas. But for those of you who are unable to attend the conference, we're happy to share the talk with you today via webinar. Just as a reminder, all phones and microphones have been muted except for that of the presenter. So if anyone has any comments or questions during the webinar, please feel free to use the questions interface in GoToMeeting. There will be several points, several slides throughout the presentation in which J.D. is going to pause and take any questions that you may have. So without further ado, I'm going to hand things over to you, J.D. And again, thank you so much for presenting with us today.
You're welcome. I'll show my screen and see what we can do to get the slides here.
Excellent.
Slideshow. And what's happening, Amy, is it's still showing. I can't see half of my presentation because it's caught up by the screen details. How can I make this go away? Ooh, that's a way to make it go away. All right, we're going now. I had to hide it down there. All right, in the next 45 minutes, we're going to learn about what a Paynter chart is and understand how it is tied to time of manufacture, which we will call TOM. We'll construct an example and apply the tool. The PDF version of this is available through Amy, and it'll be available to those that attend, so you can download it and have a copy for yourself. We'll be reviewing the power of the Paynter via risk mitigation so that we can have less expense and more predictive analysis of what's going on in the field and be able to apply it to our warranty processes. Some assumptions that you need to have when you're working with Paynter charts is that you need to know what a Pareto chart is, and you need to know the concept of chi-square. We're going to go over those briefly here. Very quickly, a Pareto is a form of a bar graph that sorts information in a high to low order, often called the 80-20 rule. I like to call it the worst first. Usually, if you have different types of failure modes, you're going to put either by percentage or by quantity the highest items first, down through to the lower items. On the right-hand side is the chi-square analysis. You will find if you're a member of the Statistics Division that they often put out working templates to members as part of being a member. And this particular template, the chi-square template, is available to members for free. It's a very nice feature of being a member of the Statistics Division. So chi-square is a quick analysis. In this little example, I have two processes, a first time and a second time. I had 125 good units, 4 bad units. In the second time frame, I had 142 units and 7 scrap units. And it does some totals. I'm not going to go through all the math here. There's some background math where it goes over observed and expected observations. But the bottom line is it tells you whether or not there's a difference between those two populations. You can do this for machines and equipment. You can do this for running processes over different shifts of an operation. and you can do a before and after scenario. But in this particular example, it actually gives you feedback saying that it's unlikely that there's a difference between these two populations. When we're working with Paynter charts, you're going to be doing a lot of comparisons with a very few pieces of returned information. So chi-square is a very helpful tool to evaluate whether or not you're seeing a difference in a return rate or not. And we use it heavily in our businesses. So what's a Paynter? It's spelled with a Y. It's a person's last name. Marvin Paynter, he went by Marv, worked for Ford Motor Company, and it's just a graphical tool used to analyze product failure. Most critically, Paynter charts rely on the time of manufacture, whether you use a week or a month, a day, an hour, a year. It just depends on what your product processes are and the finite time frames that you want to look at. Resulting graphics are often a matrix of failures or what we call stack bar graphs, stack bar charts. And these both are run generally over time, whatever those time buckets that you've determined. Data is typically expressed to be the percentage or parts per million. In this case, I believe I'm using parts per million throughout the deck. Painters are almost always used in tandem with Pareto charts so that you can see the worst first thing that you have to go knock down and make an effect to your processes. And Painters help you determine what those corrective actions need, and they help you prevent business loss by going out there and getting things sooner rather than later. It also helps you verify in the field the effectiveness of your corrective action over time. This is one type of a Paynter matrix. Since Paynter came out with these in the 80s, people have taken these by storm and they've multiplied a variety of formats. So this is just one format of many. It's not copyrighted, it's pretty much public domain, and it's just out there for people to use and sort their information in a variety of ways. In this example, I have my various months of production. They're by the time of manufacture. So here's July and August and September. I have 5 different failure modes that are being experienced. These are the total number of units I've had for these. This is actually live data from a process from a company that I was with some time ago. I can see the actual quantity that was produced in July. There were 15,000 units made in July, 16,500 in August, and so on and so forth. The yellows indicate when a corrective action was executed. With the changes in Excel, you have some really nice abilities to color code and conditionally format your cells so that you can determine, well, if I've turned it on, is my return rate or my reject rate after the fact going down? And in this particular spreadsheet, I have it conditionally formatted for a 0. If there's a 0% return for that failure mode, then it pops the cell green. So now I can see on my scorch, I have a high failure rate going on. I've executed a corrective action in yellow, and now I've gone to 0. However, in February, something pops back up again. So I don't know if I necessarily got the right corrective action or if there's another underlying cause that I missed on the first time around. Excuse me. On the contamination side, I had a low-level failure rate coming in. I executed a corrective action in February. And why this March isn't 0 is because there were some failures, but it just showed in the round-off as being a 0. But you can see that going forward that the failure rate was 0 afterwards. So typically a Paynter chart used in this manner helps you see the effectiveness of your corrective action. What I generally advise people to do now is once you show an effectivity of an improvement, then if I have another scorch problem coming up again, I would open a new line since it's a new kind of failure mode that I'm looking at. One thing that's key here is to ensure that the measurement systems analysis, the MSA review, is done. Because whatever changes you make, if your MSA is not effective, you really don't know if your changes are having the desired effect or not. In this example, this is another form. You can see, I'm going to flip back for a second. Here's the original table. Many people will use this 3-part form where you have the table on the bottom because it's hard to identify what the trends are physically looking like. Again, it's the same format. I've got the same. This is different data across other timing. Here's my time 1, time 2, time 3. I can see going across to the right my total failures of 27,000, and that's 67% of my failures, of my total failures. And now I've got on the right-hand side, I've got this bar chart, Pareto chart, that this is failure number 1 that's occurring the most. This particular Excel spreadsheet is automated. All you do is put your data in the table. All you do is put your data into the table, and the graphs automatically populate. In area 1, we refer to again that you need to have this accurate measurement system in place. You need to have an accurate measurement system in place. The number two and number 3 are different ways of showing the same thing. Number 2 is just a line graph showing the trend over time of what's happening to your PPMs. And in this case, I've got a full PPM. But what I've got is a stack bar of the PPMs for the various failure modes. The red bar itself reflects the scorch, the PPM of the scorch fallout. The next color, the pink, would represent the contamination component. I can see here that this raw material component, this third item, pops up here on my time frame 7. So it's a new failure mode that's showing up. And you can see that it turns on later in the process. But overall, my entire overall trend chart is going down. So depending on the level of detail that you're looking at, this trend chart might either be a stack bar or it just could be a line showing performance. With the bar graphs, though, with the stack bars, you can see when items turn on and off based on the colors of the stacks. That's not very evident in the line graph format in line 2. So it's helpful for me when I use these to use a stack graph component. When I look at my scorch item, we might ask ourselves what might have happened when I had effectivity here. Again, another failure mode could have popped up. I might not have solved it right the first time. There could be a variety of things going on. I would like to open this particular slide up to questions, if there's any questions that people would like to ask of Amy.
Okay, JD, we don't have any questions that have accumulated so far, but maybe we give just a minute here, see if any come through. Otherwise, I'd say we could just take them at the later slide.
Okay, that's fine.
When we pause.
I'm going to move on to the next slide then.
Okay.
When we define a stack bar painter, the time of manufacture is the key. Stack bar charts show the return data bucketed by that time of failure. In this particular example, this is years. So I've got a year A, a year B, a year C, and overall the product is performing rather normally. I've got a stable return process for my first group of returns, my second group, and so on. But in year E, I had an issue happen. I can use my chi-square analysis here to determine if my first year of returns, I've got about 60 or 70 ppm going on for year D, and all of a sudden it pops up to 125 or so in year E. And I can ask my chi-square, is this a functional difference? Usually you're going to see this return rate pop up sooner rather than later. It doesn't take a whole lot of returns to identify that there's a statistical or a significant difference in the rate of return. And then that allows you to start going into your field asking questions, to pull the product to yourself and do your analysis, and then determine, do I need to go get stuff? What do I have in-house? What do I have in stock? What do I have at locations that I could probably do some sorts or evaluation on? This prevents later costs of premium freight or overtime, or you know now that you're going to have to replace defective product, so then you can start to schedule that immediately. So it minimizes the expenses that may be incurred if you were caught flat-footed and not aware that you had this item coming up. So in this particular example, this is a live painter from a different business, and a change in the supplier of a component caused this effect. And there was a few pennies saved per component, but this cost the business money for years. And if a Paynter chart had been in use, the issue may have been identified via chi-square much sooner, within months of that release, because the field or the engineering testing didn't verify or didn't capture the failure mode that was happening during actual application. One key thing for this to work well is that you need to apply all the returns that you get to that time of manufacture very quickly. So if I get 10 parts back today and I don't analyze them for 4 months, then I'm missing out on some very live information potential to give me a pre-warning if I've got an issue going on or not. So having an effective evaluation system in process is key. The more you delay, the less effective your Paynter chart evaluation will be. Continuing on the review of this stack bar Paynter, in this case my red bars, or the bottommost color, are the units that were returned. We call those boomerangs. They infant mortality. They came back the year that they were produced. So in year D, my first year, my red bar was around that 50 part per million range. My year E, that boomerang, those returned parts, more than doubled. And it's not going to take a whole year for me to see that that's what's happening. If I look at my rate of return by time of manufacture, if I look at my year 1 returns, so here's my year 1 showing this 50-some% back to here on year F. Then I can see at year G it's significantly less. So I can track my rate of returns for my year 1 products. This bar with the horizontal stripes on it is showing my overall average, which is currently heavily biased by my previous years of returns before I had the corrective actions executed within the processes. So you can see that the year 1 return rate, those boomerangs, is starting to go down, effectively so. The year 2 returns, now these things are probably not a manufacturer issue. These are pre-fatigue failures coming on. So here I've got my year 2 items for items that were made in the first, this would be year F, and then year G. And then you can see year 3. It takes a while of disciplined approach to develop this database. What happens is many people do engineering lab testing. And the lab testing doesn't quite simulate very well what happens in the field or an application. So this ends up being an empirical set of feedback to the design engineering team. And then you can start to cross-correlate. Well, if my lab results, if my engineering test results in an environmental chamber show this, then my real-life results show that. And that allows me to start doing some real cross-comparison and enhancing the robustness of the design testing that's being done. With this, you can see that the bathtub curve, you certainly start out with your infant mortality. Those come out at the front, those boomerangs. Then your rate of return starts to go down. And technically, what your Paynter chart helps you develop is half of your bathtub curve, because normally you stop tracking when your warranty time frame ends. If you were to continue tracking product beyond that warranty time frame, you would start to see the natural failure rate start to go up until all of the product fails. But most businesses don't have return methodologies to understand what's happening in the field after that warranty, because you don't take that product back anymore. So one thing that we do is we set up a couple of customers that have high volume, and we ask them to track rate of return beyond warranty. And this way we can continue to build of the empirical side of the bathtub curve. And we just do this with a couple of customers, and then we have some agreements with them so that we can understand what that lifetime really looks like in product application. Moving on to the next slide. When we look at time manufacture, this is the key way to manage business risk. We can use an iterative chi-square analysis to check for the difference in rate of returns. Every time 1 or 2 units come back and you're proactively checking those, you can verify it against past performance to see if there's a difference or not. You can make a decision on how far to go into the value stream if you do identify an issue, and then you can say, well, do I got to go get this? What kind of failure am I experiencing? Do I need to talk to my customers or put out technical service bulletins? Do I need to make extra product now to replace things? This helps you minimize expense that you might otherwise incur if you were not adequately forewarned of this potential. It also helps you to quickly see the impact of corrective actions that you might execute. ROB, on the other hand, is what we call returns to our backyard. It does not enable what we call predictive nor preventive planning. I'll show you on the next graphic what happens. And ROB is what we call the traditional financial method. So if I made 100 units this month and I got 10 units back, I may say, well, I got a 10% return rate. But those 10 units that I got back have no reflection on the 100 units that I made this month. Those 10 units could have been made a day ago, a month ago, a year ago, or 5 years ago. So having that evaluative ability to determine where those units are coming in at really helps us understand the quality, the potential quality of the outgoing product. You also have some improper relationships that could be made. Let's go over what those are. So the traditional financial accounting is in this blue line here. So if I made 100 units and I got back 26, I've got a 26% failure rate from the financial guy's perspective. If I am bucketing my returns into the time of manufacture, I am then getting a truer picture of what the return rate for certain months are looking like. In this case, in the green circle, my operations team might look like a hero. My prior sales have low volume, but because my return rate is low, or I could have a high return or a high sales volume, low, and whatever my return rate from my previous months of lower sales, I've got a lower return rate coming in. So because of that, I look like I'm doing really good, and I'm getting a big pat on the back, but in reality, my actual return rate for production made that month is not that great. So I have risk, but I have no financial clues. I have no signals telling me that I could have a problem here. On the flip side, if I had very low sales and now I have a higher return rate coming back, it could flip my ROB chart going the other way. And then my ops guys end up getting killed because they're saying, oh, look how terrible you are, when in fact the true return on the products is the lowest that it's been in the past 6 to 8 months. So we have to understand the past practice of sales, if sales is up and sales is down. If your percentage rates change or don't change on that return rate, you can get a very improper trend going on from that return to your backyard measure. So we work very hard to help our finance teams understand that this is not a good way to predict or look at health of your warranty returns. The prediction data here, what you see in these light pink bars, is we're taking an assumption based on our past return history. We think this is what we're going to see from future returns based on our current production processes. And from here, we're able to predict with some level of accuracy what that future exposure could look like for returns and for expense. Many companies set aside reserves. They set aside money based on a return rate, and you can help proactively minimize that level of reserves if your processes are going in the right way. If your processes are going in the wrong way, you can also then predictively help your company say, look, things are not going the way we need them to. We need to set aside more money so that we're not caught flat-footed. Now, this is an example of a session worksheet. Many people use this in Excel. And what I want to do is I want to go over some details of how this sheet works out. In January, I made 100 units in manufacturing. And in January, as of June 6th, 6 months later, I've gotten 35 of those back, so I have a 35% return rate. I cannot equally compare that to June. In June, I made 100 units as well, but I've got 2 units that boomeranged back or came back right away. And that looks like I have a 2% return rate. So that's not quite an effective analysis for us. But I can look at my month 1 return rate. Over these past 2, 4, 6 months, I've had an average of almost 6% return rate. I had 10 units back, 20 units back, 30 units back. If I go across my month 1 returns, you can see compared to my overall manufacturing average that this is starting to vary in a positive manner. If I look at May, I can see that out of my 10 units, out of 500, I can see now that I'm about a 2% out of the pocket return rate for the first month. And this is hard to read in this kind of a graphical format. We'll be able to show you how the Paynter charts work to stack this graph so that you can actually see the entire stacks going down or up, depending on what's happening. The bottom line is that you can do a month-by-month analysis to see if your rate of return is proactively changing or not. And you can do this with just a few units to see if there's an effective change in that rate of return. So if I fast forward myself and I say, okay, July's coming up, and I had 2 units returned in July. In July, I had a total of 10 units come back from across the business, but 2 of them were July build, 2 of them were May build, 4 of them were March build, and 2 of them were February build. So what I would do is I would plug these values into my chart in the right spots, and then I would let the Excel spreadsheet take over the math and take over the graphing. What I'd like to do is I'd like to open and see if there's any questions on this initial sheet. On the next sheet, we show how the painters work and how everything gets turned on. But I'd like to open it up for any questions on any detail on this particular slide.
JD, we do have a few questions that have accumulated since slide 8.
Okay.
Would you like those to be held towards the end, or do you want to give the audience a chance to maybe look at the slide for a little bit while we discuss some of the other questions?
Well, let's go ahead to slide 8 and we'll answer the question.
Okay. So the first question here is, can you expand on the comment regarding measurement system analysis, consequences, etc.?
Can I expand on the comment regarding measurement system analysis consequences? So if the measurement system analysis is incorrect, let's say you have in excess of 10% variables gauge error, then as you make a process adjustment and your people are then measuring the new results, if there's gauge error inherent in the process, you will have errors in the results of what you're trying to read. You also need to do, if it's an attribute-based process, like if you're looking for scratches and dings and porosity, things that are visually required, you need to do what's called an attribute agreement analysis. This will help you make sure that people are classifying the rejects in the right categories, which is needed for the effectiveness of the Pareto charts.
Okay. Thank you. Another quick question here. Someone is asking, should the stacked bars, would they be more useful if they were stacked by month rather than year?
Absolutely. It depends on what your process is. Some processes are by year, some are by month, some are by day, some are by hour. It just depends. In this example, I'm just showing by years.
Okay, thank you. Someone is asking, the value shown for the average on slides 7 and 8, if the underlying process is not stable, should we show the average at all?
That's a good question. If you don't know that the underlying process is not stable, you're not going to get 15, 20, 30 years of data sometimes. So you're constantly changing the process. The average is just used as an immediate comparative point. It's a fair question. People do ask that a lot. Paynter found a lot of value in doing the quick visual analysis. If I can see some stabilization across 2 or 3, you don't have a big sample size here. So you just have to see what your assumptions are and determine if you feel that your processes are stable enough to make the assumption.
Okay, thank you. Another question here. How would you track a product that fails, gets repaired under warranty, and then fails again at a later date?
How would I track a product that fails, and then what?
Gets repaired under warranty and then fails again at a later date.
Gets repaired through warranty and fails again at a later date. It would depend if it failed for the same failure mode or for a different failure mode. You would have to have good tracking systems for your repair numbers. There would be traceability in your tracking system, hopefully. If you don't have repair traceability, then that would be a risk of you not knowing that it came up again. Depending on the quantity produced and the quantity returned, it may or may not affect your overall data. So it's just something you have to be aware of as you're analyzing your processes.
Yeah, I agree. And there's a follow-up question, which I think you pretty much addressed. It just depends. The follow-up question is, does the unit get tracked from the original date of manufacture, or does the clock start over from the date of the warranty repair?
Yeah, whether or not you restart the clock when you do a warranty repair is a business decision. And if you feel that the effectiveness of the repair process is in question, I would create a separate lock for those. That's how I would manage it. But again, depends on quantity and what the failure modes that are being experienced are.
Okay, thank you. Those are all the questions. The last comment here is someone is saying, we call this analysis by vintage.
They call it what?
It just says, we call this analysis by vintage.
By vintage. Yeah, that is a term that I've heard.
Okay, so I think we're ready to proceed if you are.
Okay, so now we are on slide 12. So if I analyze the month one return rates, I see that my overall average was 5.8% previously. Okay, and now I have a decision to make. If I want to create what I call my ghost bars or my predictive bars, and there's some liberties being taken here, no doubt about it. This wouldn't pass all of the statistical rigor that we want to put out. I don't have 30 samples. I'm not sure if I'm normally distributed. Normally with returns, you're not. It's a sound or a Weibull base. So I'm just trying to see if things are changing effectively over time. We try to look at the last 2 or 3 months, and it depends on how long your supply chain time is. If you make a product and it sits in your own inventory for a month, and then it goes to a warehouse and it sits there for a month, and then it goes to a customer and it sits there for a month, and then it's finally used, it could be 3 or 4 months before you're getting any field feedback. So depending on how long your supply chain cycle time is going to depend on how you create these averages for your stack bar. In this example, we used a 2-month average, but this is very, very business dependent. In the current business that I'm at, we literally use a 6-month time frame. But for ease of understanding, we just use 2 months for this example. So in this case, I've got my last 2 months of May and June that had 2% of boomerang returns. First month made, first month out. And then they came back right away. But you can see that my previous month return rates were quite higher. If I go now to my month 2, they've been out there for 2 months. And here's my return rate. You can see, again, I'm starting to see an impact. If I look in my Paynter chart, I'm going to flip back for just a second. On the very bottom of the worksheet, most people will identify the various corrective actions that happened and when they happened. So you can see that there was an April corrective action here to reduce infant mortality or boomerang failures. There was another corrective action implemented in May to reduce premature fatigue failures. That may or may not have an impact on those infant mortalities. So with that said, I need to see if I'm going to have my second corrective action might not show up for several months. My internal design testing tells me that it's going to be effective, but I'm going to have to wait to see if the field results are going to catch up to that. In the meantime, I will run my 2-month failures, and you can see that these are staggered. If I look at my month 4, my corrective action hasn't hit yet. This is still February and March, returns coming back in February and March. So I'm not going to get that benefit of my predictive bars showing any improvement in rate of return. I can't make that assumption yet because my product's not been that long in the field. I have to wait and see. In the meantime, I have to take the hit, assuming that there's going to be zero effect at this point in time. What I can do now, assuming in this case I'm pretending I have a 6-month warranty time frame. Most products have years or decades, but you can apply the same concept and you can build this database. So as I've established my percentage or PPM table, you can visually glance at how it's doing, but it's much more powerful to look at what I call the Paynter stack bar. So here I can see my January 10%, my February 10% in the reds, which is reflecting my month 1. I can see my pink, which is my second month of return, which is reflecting my month 2, and you can see what's happening there. And then the month 3, you can see that this, I don't even know what this color is, this puce, is showing a much smaller rate of return here. Maybe this is my fatigue failure showing, my fatigue fix showing up, I don't know. That didn't happen until May, so it shouldn't be showing up soon. But we'll see if these are my fatigue failures. So right now, my ghost bars or my predictive bars, I'm getting some dial-in showing that I'm getting some effectivity right away out of the box, but I can't make that many assumptions about the future forward, so I have to hold on to the previous data of what it is. So I ask myself, is this an acceptable quality level for me? Is this what I want? And if it's considered acceptable, maybe I stop there and I go on to another product. If it's not acceptable, then I have to continue analyzing my returns against the Pareto chart and saying, what's next? What can I do next to get my next hit? In this case, what I've done is I've filled out the analysis worksheet for you that we did 2 sheets ago, taking this return data and plugging it into the actual worksheet. Now it's color-coded for you. So that you can see these 2 returns for July are in here. I can see these 2 returns for May, which is a month 3, are in here. This is not a fall off a truck, easy, anybody can do this day one. It does take some engineering analysis, some skill with Excel. Been talking with various teams to see how we can automate this process and make it a little easier for the teams to evaluate. But we're getting a lot of power from these painters in terms of predictively telling us what the stacks are doing and what's happening empirically in the field. The blue ones, you can see how the blue items have been populated, and then the beige ones have been populated accordingly. So now, as I'm future forwarding 3 more months, you can see my percent return rates are going down. If you remember quite earlier, my month 1 was 5.8, and it's now 4.0. So now let's see what my new painters are looking like. And while the magnitudes are changed, this is based on real data from real business environments. So in this example, we still continue to use the 2 months of averaging information. You can see that prior to this, my 2 months earlier was at 2%, but now I'm down to 1%. So my boomerang, my infant mortality failures have gone down quite a bit. You can see my month 2 is almost non-existent. My month 3 is almost non-existent. And this is continuing to drive downward. So there's a dramatic reduction in your future returns if you're able to verify the effectiveness of your corrective actions. And if I look at now how much I'm going to have to set aside for reserves, or what's my true business risk going forward, I still have all this stuff out in the field. I don't know when it's going to come back. Those are all little time bombs out there waiting for me. And product that was built in this time frame is going to be coming back in my current time frame. So I have to keep putting these back into their time of manufacture so that I don't get biased in my rate of return values and improperly think that that the corrective action processes didn't make a change. But when I look at these now side by side, I use these ghost bars to help me visualize potential risk, but they also help me see the future to some degree. 3 months later, this is now what my graph looks like, and you can see that my bars, my predictive bars, continue to drive down. My return data, for this to work, my return data needs to be analyzed and bucketed quickly so that I can get those Paynter benefits of making sure that whatever fixes I put into play did indeed happen. And the reason why the height of these stacks went down so dramatically was primarily I'm using a 2-month window here. If I was using a 6-month window, these would be coming down a lot more slowly. If I was using a 12-month window, it would be a lot more gradual. But I would still have that ability to determine downward trend or look for overall analysis. Figure 2 is just, when you start a Paynter evaluation, it's never perfect. You're starting in the middle of something. So sometimes you have to populate information backwards. And that's exactly what we've done in this example. So I've got the ghost bars going backwards based on my existing results so that I can see my baselines if I've made any difference. So these are some real business results. We've used the Paynters proactively to identify if corrective action is effective. It helps us plan for business risk and reserves. So if I've got to go out and get things, it's a little bit more on my own terms than the customer doing a knee-jerk reaction with me and me having to put premium freight up there and overtime.
I'm just going up my lunch.
You're
ready to go. You're probably ready to eat your lunch right around the time you called it. No, it calls at 11. 11.
Well, somebody's not muted.
I've been piecing together chocolate and nuts and dried fruit out of my drawer.
I think we need someone to mute their microphone there.
Of what he actually wanted to talk about, and then just nonstop. I love it. I just love the call with Sandy too. I'm like, yeah, clearly.
I'll try and talk over it. If your phone's not on mute, can you please put your phones on mute?
Everything.
The ability to build empirical results and cross-matching back to your design and engineering testing is a huge benefit here. So the ability to partner with your engineering teams is key. Now, in this example, this is a percent of year-over-year reductions. In this product one, in the first year, we had a 40% reduction in returns, in external returns for this product. The second product, it was a 35% reduction. Third product was almost a 50% reduction. When people execute Paynters rapidly and they tie the corrective action to what they're seeing and they bucket things to time of manufacture, you're typically able to see very rapid results. The second year, because you've hit your low-hanging fruit, your second year, while impactful, isn't usually as big as an effect as your first year. It does depend, though, on what type of failures you're seeing. So if your failures are based on fatigue and design, then you might get a bigger bang for your buck the second year instead of the first year. It just depends on where in the failure cycle your product is at. But those are real business results from a company that I've been supporting. In terms of controlling, if you've got this process in place, you use Paynters to verify and contain on your terms. and to understand product performance empirically versus the engineering side. Once you have a working data system, do everything you can to automate it. The problem that you'll run into is you get one or two guys that are really good at running these data, and they're excellent at it. You get some great engineers, and they go down these rabbit holes, and they're able to really slice and dice the Paretos for you. But if they get promoted or if they leave, you've lost that whole ability to analyze your process. So it's key to try and automate it as much as possible and cross-train others on the tool. Painters require thought. They do require some intelligent use of skills and some understanding of analysis. You have to be able to be comfortable with chi-square. You have to know how to use Paretos. You have to be effective with working with production, design, and your supply chain teams to assess for change. And you need to ensure that your system fixes are sustainable, or they'll just pop up again. In this case, this is real data results. This was tied to cost of goods sold. Typically, it's not very helpful to tie cost results to sales. Sales margins change, and sales mix often changes. So you don't understand truly the margin recovery potential that you have in your product if you don't compare it to cost of goods sold. And COGS is a very nice way to see what you can recover from a margin impact perspective. We do a lot of color coding so that we can see when corrective actions are implemented. And those are real business results. There was over a 37% reduction in warranty expense from year 1 to year 3 in this particular live example. So in the past 45 minutes, we've learned about what a Paynter chart is. We've determined how it is tied to time of manufacture. We've constructed, I've walked you through how to construct an example and apply the tool. I'll review the power of the painter's ability to mitigate risk. And we've applied it to predictive warranty analysis. So I'm going to open this up for questions.
Thank you, JD. We do have just one more question that has come in. Someone is asking how the ghost bars are calculated.
How the ghost bars are calculated. All right, so let's go right. This example is a little bit more clear. So in month 1, I have a 2% average going on, so you can see that this is a 2% bar. Month 2 is a 2% bar, so I've got another 2%er going on here. Month 3 is a 3% bar. You can see it's a little wider. I've got a 3. So this is, if I did nothing and I assumed that all of my averages hit, this is what I would expect in terms of a rate of return for product I haven't produced yet. If I have a blended month, I've got a couple of months of return, but I don't have my full future. So in this case, I'm looking at my June data. So here's my June of 2%. And then it's going to now run, this is a 3%er, it's going to run the averages, it's going to mix my real percentages versus my ghost percentages. So that's how it's calculated. It's a hybrid of real data versus predictive data based on the averaging of the future time. And these are set up automated, so Excel does them right for you.
Okay, thank you. Another question here. Well, first someone commented, great presentation, JD. Thank you very much.
You're welcome.
A question is, would Minitab or Jump offer a chi-square or Paynter type software, or is the presenter's experience only via Excel?
Oh, I do this all in Minitab. I love Minitab. Yes, I do all the chi-square work in Minitab. We do, most of this gets into Minitab files, but Minitab doesn't yet enable us to make the stack graph, which is why I have to cross-dump it back into Excel.
Okay. Someone is chiming in here. An alternative approach could be to use reliability analysis and plot the cumulative distribution function for each shipment month. Also, the CDF for each failure mode can be plotted by treating the different failure modes as competing risks.
Sure, you can use the cumulative distribution function. That helps. This is a lot more visual. Most people aren't familiar with the calculus modes and doing the integration functions to do the CDF, but that is definitely another way to do this. We actually find this is easier and to explain to people when you see the graphs. I can see my first month out. I can see my second month out. Oftentimes, people put a lot of stock in the engineering testing results, and they forget, or they don't close that backdoor loop of how does that really cross-correlate to what happens in the field. Because you don't have all that variability in the lab that you do in field application. Customers don't take care of your product and do it the same way every time when they're using it in real life. So that's something that we have to be aware of when we're cross-comparing.
Yes. Okay. Thank you. I don't see any further questions, JD. So as we're approaching the end of our time here, I understand that people might want to drop off. For those of you who are still on the line, we will be making a recording of this presentation available for later viewing, and that can be found on the division's YouTube channel. We usually post it within probably by this evening. And so be sure that you share the presentation with the colleagues, coworkers, or anyone who you think might have an interest. For reference, the division's YouTube channel is youtube.com/ASQStatsDivision. That's youtube.com/ASQStatsDivision. Okay, so excellent presentation, JD, and we thank you again for your time, and I hope that everyone on the phone has enjoyed the presentation. Our next webinar is expected to be during the first week of June. Details will soon be announced on the division's LinkedIn group page, as well as on our website and email newsletter. So be sure to mark your calendars. And thank you again, JD. I hope everyone has a great day.
You're welcome, Amy. Thank you.
Thank you.